Okay, last lesson of the unit. You're not going to need a calculator for this, but you want to bear with me through the whole video. Okay, absolute value. We've talked about that before. It's counting spaces between the value and 0 on a number line. That's how it's defined. So absolute value of 3, 1, 2, 3. We've done this before in this class. Absolute value of negative 4, so 1, 2, 3, 4. Notice how you don't label distance as negative, okay? Absolute value of negative 6 to 0, 1, 2, 3, 4, 5, 6. So 6, 2, 1, 2. So basically, this is 5, this is 5, this is 6, and this is 6. Now that we got that out of the way. Now, this next page is a bunch of garbage, okay? So turn past it. Now you're going to learn about a new type of graph today. So far, really, we've only graphed lines, okay? Now you're going to learn a different. This is not a line. It says y equals the absolute value of x, okay? I'm going to start this off by making an input-output table, but I'm not going to use this on the assignment. It takes too long, okay? But I need to show you how it works and why the graph looks like it does. So put 0 in the middle and just pick 3 outputs in the positive, 1, 2, 3, then 3 outputs in the negative, okay? So now y equals the absolute value of x. So I'm going to put absolute value of x, absolute value of x, absolute value of x, absolute value of x. Don't roll your eyes. We're not doing this for the rest of the problems, just this one. So if I input 3 into the function for the x, it's for the absolute value of 3 equals 3. So you got 3, 3. Now if I put 2 in for x, absolute value of 2, how far is it from 2 to 0? It's 2. So 2, 2. This is x, this is y. I'm not going to keep putting that, it'll just run down. So I put 1 in for x, the absolute value of 1 is 1. So that's 1, 1. Now if I put 0 in for x, the absolute value of 0 is 0, so 0, 0. Now put negative 1 in for x. How far is it from negative 1 to 0? It's 1. See, negative 1 to 0, 1. So we're back to 1. So negative 1 goes with 1. And negative 2, how far is it from negative 2 to 0? Well, it's 2. So negative 2, 2. Then I put negative 3 in for x. The absolute value of negative 3 is 3. So you got negative 3, 3. Now as you can see, I've got some y's that repeat, some of my outputs. Now remember, x is called the domain, y is called the range. You can have repeats in the range, okay, and it's still a function. None of my x's repeat themselves down here, 3, 2, 1, 0, negative 1, negative 2, negative 3. But my y outputs, some of them repeat, and that's fine on a function, because there was a test we took where you had to put if it was a function or not a function. You can't have any repeats for your x. So 3, 3, you go right 3, up 3. 2, 2, you go right 2, up 2. 1, 1, you go right 1, up 1. 0, 0 is in the middle. Okay. Negative 1, 1, left 1, up 1. Negative 2, 2, left 2, up 2. Negative 3, 3, left 3, up 3. Now, you don't need a ruler. It makes a V shape. Okay. Now I want you to circle that point, and I want you to label it 0, 0. This has a term. It's known as the vertex. It's the low point of the absolute value graph right here. Because as you can see with your outputs, 0 is the lowest you can get. Okay? 0 is the lowest you can get. Now, let's discover how we do that without all that table nonsense. Okay? You know this makes a V. When you see the absolute value and you have to put it on a graph, it's going to make a V, the XY relationship. So, you're going to write the word vertex. And for now, as long as there's not any other numbers there, the XY coordinate for the vertex is 0, 0, just like it was here. So you would plot the point at 0, 0. Now it makes a V. So then what I do is I go right 1, up 1, right 1, up 1, right 1, up 1. Just do it 3 times. Now you go back to the vertex and you go left 1, up 1, left 1, up 1, left 1, up 1. Okay? So that's a quicker way to get the same graph down. And that's how we're going to be doing it. But unfortunately, they start throwing some numbers into the equation. So we have y equals the absolute value of x plus 4. Then after the absolute value, we have a subtraction operation of 3. Now, graph the equation, identify the domain and range. I will talk about the domain and range after I get my function graphed. Okay, it's not going to be hard. Okay. Now we know when we see the absolute x inside the absolute value, it makes a V shape. So we put vertex, and that's going to be an XY coordinate. Okay, so here's how you identify the vertex. Put a box around your absolute value and just focus in on that. Okay. Remember, back to the previous page, the lowest output I got for y for my absolute value was 0. Okay. So what we're trying to find is what value for x that when I add 4 would give me an absolute value of 0. Well, here's what you're going to do. You're going to put x plus 4, and you're just going to set that equal to 0. Then you're going to find the x value that would make it 0. So you're going to minus 4. So x would be negative 4. Okay. So what it does is it shifts the vertex from the 0 left 4. Okay. Now you can probably find the y in your head. If you put negative 4 in for x, what's negative 4 plus 4? It's 0, and that's the point, but you have a minus 3 here. 0 minus 3 is negative 3. So this point this right here is going to be your y value. Because if I would substitute negative 4 in for x, a negative 4 plus a 4 is 0, which is the lowest an absolute value could be, okay? So 0, and then subtract 3. You'd be at negative 3. Okay, this part would be 0, but then when I minus 3, I would be at negative 3. So plot that point. Go left 3 down 3. Or left 4 down 3. 1, 2, 3, 4, 1, 2, 3. Then from there, as long as there's not a negative in front, okay, you write 1 up 1, right 1 up 1, right 1 up 1. Just make 3 on each side. Left 1 up 1, left 1 up 1, left 1 up 1. Okay. All right, and there's your V. So what those values did is it shifts the V. Okay. Negative 4, negative 3 is a vertex instead of 0, 0. Okay, now here's what you're going to do for your domain. Domain is your possible x values. Now, if there's arrows on both sides, which there is, because it's continuous both ways this way, your domain is all. X can be any number. You can put any number in for x. But the range is a little bit different. I want you to circle the vertex point and find out where you're at on the y-axis. The range is your possible values for y. So here's y. Negative 1, negative 2, negative 3. So you put y with negative 3, and then what happens from negative 3? It goes upward. It rises. Okay? From that point, it's rising in each direction, but it's rising. Okay? So if it's rising, then y would be greater than or equal, okay? And that's going to be, the domain's always going to be all today, okay? We don't really restrict domains until you get to Algebra 2, okay? All right, next one. So I see the absolute value. I put vertex, x, y. So my x value at the vertex is whatever makes the absolute value 0. So you put x minus 2 equal to 0. So now I'm going to add 2. So now x equals 2. Okay. Now 2 minus 2 is 0, and then you have the 4, positive 4. Okay. So 2, 4, write 2 up 4. Okay, then from there that's your vertex. Now you construct the rest of your V. Okay, as long as there's not a negative there. So right 1 up 1, right 1 up 1, right 1 up 1. Then left 1 up 1, left 1 up 1, left 1 up 1. Okay. Okay, and again, the domain is going to be all on all these. It's your possible x values. I could put any number in for x, but the range is restricted. Okay. It's constricted. So you circle that. Now where are you at on the y-axis with that point? 1, 2, 3, 4. So like the y, this one, it starts at 4 and then it rises from there. Okay? So you put y with 4 greater than or equal. Okay? Next problem, y equals the absolute value of x plus 3. So, vertex. Again, you're not doing a slope on these, okay? The absolute value makes it a v. So, just focusing on your absolute value. Set the expression inside equal to 0, because that's a low point an absolute value could ever be equal to. So subtract 3, subtract 3. Because on that very first problem I did, the very first graphing problem I did in this packet, 0 is the smallest an absolute value could ever be equal to. Because if you put a negative inside, it always comes out as positive. So it would be negative 3 for the x. Okay. Now, if there's nothing outside, you're going to put a plus 0. So, I mean, negative 3 plus 3 is 0, plus 0 would still be 0. So you go left 3, and you don't move up or down at all. Okay? Then from there, right 1, up 1, left 1, up 1. Just do it again, fill it out. And that's how you can sketch it very quickly. Okay, domain, all. Range, where are you at on the y? The y. Well, you're right in the middle, so you're at 0. See, and also y equals 0 at that point. So you put y with 0, 0, and from there it goes up. So it's greater than or equal. Okay. Okay, next problem. Vertex. Now just focus on your absolute value. So in there is just x, so we're just going to put x equals 0, so I don't have to do anything, so the x is 0. Okay. Now if I put 0 in for x, take away the 5, you're going to get negative 5 out of that. Okay. So 0, I don't go right or left, I go down 5. 1, 2, 3, 4, 5. Okay, so it's just a vertical shift from the middle. There's no horizontal shift because x doesn't have anything inside of its absolute value. So right 1, up 1. Okay. And you make it. So the domain, that's all, because x, domain's your possible x. Now range, you put your y, because the range, you are constricted, okay? So on this vertex point, y is equal to negative 5. Okay, 1, 2, 3, 4, 5. Then from the negative 5, you're rising, so it would be greater than or equal to. Now, I am going to switch the game here so it goes even quicker. Okay. Here's what you're going to do. Okay, so that way is a little bit longer. This way is even shorter. Okay. The vertex can also be found this way, and this is quicker, even quicker, more efficient. Inside the absolute value, the number inside is called the h value because it's a horizontal shift. It shifts it across. The outside is called a k value. Why those are your variables, I'm not sure, but it's h and k. I can't answer that. To find your x, you take the opposite of h in the equation. So it's negative 3 minus 3. You're going to switch it to positive 3. Now the y is always just going to be whatever your k value is, but don't switch that one to the opposite. Opposite of h, k. So negative 4. Minus, you'll put it in as a negative. So you go 3. Write 3 down 4. Okay, there's no negative in front of the absolute value, so you open it upward, okay? Just 1 to 1 that way. Now the only time it wouldn't be 1 to 1 is if you had a multiplying number in front of the absolute value. You're not going to see that today. Okay. Okay, now the ranges, the domain's all. Now on the range, negative 1, 2, 3, 4. So negative 4 is where that vertex point's at. And from there it rises. See, I'm at negative 4 on y, and then from there the graph goes upward, so it's greater than or equal to negative 4. Okay, next problem. Again, I'm going to use the HK. Okay, inside is H, outside is K. Now, if there would be a number in front of the absolute value with a multiplier, you would label that A, but you're not going to see that in the foreseeable future. Okay, so vertex, opposite of H, so that would be -2. And the Y value is simply your K, so it would be +3. So go left 2, up 3. Okay, no negatives, so open it upward. Just 3 points on each side of the vertex, okay? It's not hard to do. Okay, so as you can see, the very first problem I did, the vertex was in the middle, but having these values here, this shifts it right, left, okay, kind of the opposite of what it says in the equation. This shifts it up, down. Okay, so domain's all, so mark that point. On the y-axis, you are at 1, 2, 3. So you put y with 3 greater than or equal. Okay, next problem. Y equals the absolute value of x minus 1. Now this is an h value. It's inside, so I put a +0, so I have a k to go with it. So if I don't have an h or k, you're going to see me put a 0 in there. So vertex. Opposite of h, and then k. Switch your -1 to a +1, and your k is a 0. So it's 1, 0. Then right 1, up 1. Okay. Sorry, I forgot to write range on that one. I'm an idiot. Okay. And I misspelled domain. Okay, I don't know what I was thinking there. Okay. And I forgot domain on this one. D-O-M-A-I-N. Okay. Okay, so where am I at on the y? I know that the domain's all. Okay, the domain's not restricted. Okay, but you do have constraints on the range because right there, since you're right in the middle of the y-axis, y equals 0. And you can also just look over here and see that it's 0. So y was 0, greater than or equal. Okay. Next one, domain. Okay, all right, first off, let's get the vertex. Now, this time I don't have a number inside of the absolute value, so I put a +0. And that's your h, that's your k. So vertex. Now use your brain here. Opposite of h. Dude, 0 doesn't have an opposite. So if it's 0, you just put 0. And then k. So 2. So 0, 2 is a vertex. So you don't move right or left, you go up 2. Which makes sense, because if there's an h of 0, there's no horizontal shift. The k is a vertical shift. Okay. So anytime you see that absolute value, you need to write the word vertex down. Okay. All right, domains all, range, put your, well, there is a constraint on the range. Okay. Because you got this point here. So it's like it starts at 2, and then from there it goes upward, okay? So 2 greater than or equal. Okay, got 3 more, be patient, okay? Okay, now we have a negative in front of the absolute value. You're like, so do I put a -1 there? No, okay? So you're going to do the same thing. This is h, this is k. So essentially, so I have x, y, so opposite of h and k. So opposite of h, take opposite of h, -2. Because you remember when I was first doing these problems, I took the inside, set it equal to 0, and -2 from 0, that's -2, because that's what puts the absolute value to 0. And the k, -3. So you go left 2, down 3. Now this is easy not to pay attention to, but this negative, you do what's called invert, okay? That means instead of up 1 right, you go down 1 right, down 1 right, down 1 right, and the same here. So you find the vertex the same way, but you just invert the V upside down. Okay, so it's upside down. And that changes your range a little bit, okay? So you mark your range, you put y equals -3, 1, 2, 3, and you can also just look over there to find the y vertex. Now from there, it's falling, okay? So when it goes down, we don't use greater than. We put y with -3, but then that changes now to a less than or equal -3 constraint. Because from -3, it goes downward. Okay, next one. So vertex. So inside we have h, and then if I don't have anything outside, I put a +0, and that's my k. So opposite of h. So it's +3. And then your y, that's your k, 0. So you go right 3, and you don't have a vertical shift, okay, only horizontal. Okay, and we have that negative sign, so the v has to be inverted. So instead of up, you go down right, down right, down right. Okay, right there. There you go. Okay, so domains all. Put your y. You can see your y over there. You can just look at your graph and see that this vertex right there is 0. Okay. Y equals 0. So you put y with 0, and it goes downward from there. So less than or equal. Okay, one more. Finally, huh? Y equals negative absolute value x plus 2. So when I see that negative, I'm just going to write invert right away. Okay, so I'm going to find my vertex the same way. Opposite of h, k. Now, if you don't have anything inside the absolute value with x, you put a +0 because that's your h. And then the outside, after the absolute value has ended, what I have added or subtracted is going to be our k. Remember, 0 doesn't have an opposite. If it's 0, it's just 0. Think of a number line. You know how there's only one 0? So there really is no opposite. So then k is +2. So 0, 2. Okay. Then, remember, you have to invert. So you go down instead of up. Same thing. This is still our vertex, but we just go down. Okay. Okay, so y equals, so you're at 2 on the y-axis, or you can just look over there. So domains all. The range, you put y with your 2, and from there, you're going down.